Kayla as the president of AIChE UI SC, and I think as we already experienced on yesterday's software training, I think that we have already gained so many new insights and also valuable knowledge from this session. So today we are really excited to continue to build our understanding even further with RTsim. Once again, we are truly grateful for this collaboration and the opportunity to keep learning through this hands-on experience. And lastly, I also hope that everyone here can continue to gain valuable insight and make the most out of this session. Thank you. I think that's all from me, and I hope you all have a great session ahead.
Thank you, Kak Kayla, for the warm speech. Next, we will move on to our main session where our mentor will be guiding us through today's material. Without further ado, the time is yours.
Yeah, good Saturday, dear participants and AIChE team. It's an honor to have a collaboration with you and introduce you our simulators and our software. I think we can start. Please let me know how you're hearing me. Is all okay? Yeah, okay, thank you. And I have been on the previous webinar, and yesterday we have explored the main interface of RTsim career, and one of the simplest simulator, buffer tank, and reflux tank. And today we will explore a new type of exploration of new type of facility on the refinery and then in energy industry. It is heat transfer and heat exchanger systems. I think buffer tank and the reflux tank. It is gas and liquid transferring units, and heat exchanger and reboiler. It is heat transferring facilities. So let's open heat exchanger in technological process management mode. And here on the main screen, on the main field chart, you can see the simplest heat exchanger system. Here is a heating medium, here is a coolant medium. And to better understand how all equations are working in heat exchanger system, let's learn some theory. And today we will learn the main functions of heat exchanger equipment and how energy transfer from between two mediums, between two streams, without any mixing and mass mixing and without chemical reactions, and definitely which stream, the process stream, and which is a utility stream. And sometimes, not in our simulators, in educational simulators, but in real digital twins, both streams, cooling and heating mediums, can be process streams. And sure, we are learning these scenarios to apply these skills and knowledges for safe operating principles, for safe operating, and learn how to correctly start up and shut down such equipment and solve some unpleasant situations. In the second part of our today's webinar, we will analyze reboiler dynamic under increase the heat input and understand more complexes system. And one of the main system that operates and help us on a real plant, it is emergency shutdown system. And I will show you how ACD system are working and help us in this simulator. And at the last part, me and Alina will announce a competition among participants of this intensive. Yeah, and what is a heat exchanger? Heat exchanger is energy transferring system without mass mixing and chemical reactions. In the simplest, here is shell and tube heat exchanger. Here is two streams, heating medium and cooling medium. And you see that streams direct face to face. And it's made because we understand that in a cooling medium, temperature at the outlet will be sure higher than the temperature in the inlet. And the same situation with the heating. And here is no mass transfer, and working, as I said, working mixture, working stream can be heating medium, so it can be heat, or heat exchanger can heat and cool our working stream. And you should know that in real production, sometimes we need heat our working stream, in particular when natural gas comes to refinery. It's we should heat it, and it will increase our economical efficiency. Because if we will heat in a Coleman, or we will work with cool natural gas, we will waste a lot of energy, a lot of raw material, a lot of other materials, and we'll lose our money. So heating increase our economical efficiency. But when we cooling our heating, our stream, our working stream, in part it can be when we already have a product, because you should know that polymers obtain in high temperature and high pressure conditions, but when they have granules, small balls, they should be common temperature, and sure our heat exchanger system, not shell and tube, other heat exchanger system, help us cool our product before packaging all other parts. Yeah, and about typical other refinery and chemical production applications is the preheating feed, as I said, cooling product, condensation, because some polymers obtain via condensation technology, sure, heat recovery network, and there's sometimes some chemical reactions can be exothermal or endothermal. So we can use this energy to not waste and pollute our atmosphere by energy. And reflux cooling loops around columns, because we will show you bottom of column or absorption column and another column always should be heating, and reflux help us to do it. Yeah, now there are a lot of types of heat exchangers. One of the common used, in particular in oil refinery, it is shell and tube heat exchanger, and in our operator training simulator RTsim career, we have a digital twin of real shell and tube heat exchanger. And I think all of you know that all of you know air coolers, fan refiners, and no cooling water in personal computers, and plate exchangers you can see on refrigerators, and spiral and double pipe heat exchanger in special industries. And why shell and tube heat exchanger is commonly used in refinery and chemical engineering, because it's handless with pressure, temperature, and robust and maintainable while standardized, and it's easy to regulate the streams of coolant or cooler or heating medium. And one of the main equation is driving force. Is a driving force and heat duty, and sure, flow rate and inlet temperature, influence outlet temperature, and phase behavior matter. Cooling may condense, heating may vaporize, but it's connected with reboiler. And import process indicator in our scenario that cools vapor fraction 0. I will show you a device that show us the condensation ratio between liquid and vapor. And about Reboiler, because now we are covering all theory connected with heat exchanger system, and later the later we'll show it and see it in our software. So Reboiler is a boiling unit, mostly connected with rectification with distillation column, and it supplies heat at the bottoms of the column, generates boil up vapor with rises through the column, and vapor liquid contact enables separation. And why it matters? Boil up rays strongly through the column, and a vapor contact enable separation. And why is matter? Boil up rate strongly influences product purity and must maintain safe liquid in a reboiler and alarm warming the emergency. Yeah, and let's back to our simulators. Here you can see the shell and tube heat exchanger. And Alina explained how to use top panel bottoms on yesterday's webinar. If you weren't yesterday, please join to our WhatsApp community, and their link for recorded webinar on our YouTube channel. Assign our assignment, and in our social medias, including LinkedIn, Telegram, WhatsApp community, and show YouTube channel, you can see a lot of, you can find a lot of useful content and knowledges for your career and energy industry. And as always, we use technological flow sheet and piping instrumentation diagram feature because it makes our workspace more convenient. And the main unit, as I said, is heat exchanger. And about left part, here red pipeline, red pipe, red color pipes. So we understand that it is heating heating medium, heating medium of our heat exchanger system, and in this case is feedstock from the unit, and after cooling off this working stream is direct outside of battery limit. And here we see the drainage and other green color pipes. It is cooling medium. We can say it coolant, and this stream help us cool our working stream. And all production process controlled by devices and valves. And Alina said on the first webinar that device names means P means flow rate, T means pressure, P means pressure, T means temperature. And in a heat exchanger, there are new type of devices. Naming rules the same. Q means quantity. Distillate quantity is a ratio between vapor phase and total quantity. And consequently, 1 is maximum value of vapor phase in the system, and 0 means that all production in the liquid phase. Now let's open the trend, but first of all, we should start calculation. Let's find here T. Yeah, 0 means that all products in liquid phase, 1, 0 that all stream in a vapor phase. And sometimes operators should condense the product as much as possible. So we need to increase the quantity of cooling agent, cooling medium, when we condense maximum raw material. We can change the temperature in all system, but we can change the amount of this cooling agent. It's depends on operating degree of raw material, temperature, device, tier 6. So let's find here temperature device. The main temperature device is tier 6 on the heating medium, but it regulates the opening of cooling pipe or shutter valve. And at this temperature device that regulates the temperature of raw material of a cooling agent, the outlet of heat exchanger. I draw your attention that this device measure the temperature of heating medium, but regulates the opening degree of shutter valve, of control valve on cooling medium. So we can set this, we can set on this device, adjust the set point, but it will regulate the amount of coolant. So accordingly, if we want to reduce the temperature of raw material and respectively increase the amount of liquid in the outgoing substance, we have to increase the flow rate of the cooling agent. And second trend and second device that we need is a quantity device at the outlet of heat exchanger. So let's open strand. And at this strand, we can see the changes in the distillation rate. Now we can see that about the distillation ratio between vapor and liquid phase in our working stream is about 0.5. So what we should do now? And let's go to our distributed control system, because field workstation simulate all all actions on the field and all parameters. And some of actions can be done by operator on the field, but DCS simulate the control room. And let's open the control valve of our temperature device. And what we can do now, now we can see that it is in automatic mode, but our aim its condensed product much as possible. So what it means that on a quantity device should be 0. To do this, we should manipulate the temperature device. On the temperature device, let's open. Now let's change the adjust a new set point for our temperature device in the CV window here. Now 20 to 110 Celsius degree. But let's click on CV window and enter here 100. And let's see what happens on the trends. Here we see that the temperature regards have gradually begin to fall, and they're approaching 100 degrees in a few seconds. And the fraction of distillation has also begun to decrease. Accordingly, there is even more liquid in the product as outlet, but our goal is for all fraction is this distillation to be 0, so that pure liquid flows. And to get closer to this value, I suggest completely open the cooling agent flow. To do this, let's switch our temperature device to automatic mode, to manual mode. And now we can directly manipulate, open or close control valve TV6. And let's and now to do this, we should click on new window and enter here value of opening degree. If we want fully open our control valve, we should enter here 100, because 100 is the fully opening degree. And about values. Now we see that the flow rate of our working heating media is 43,000 kilograms per hour, and heat exchange and flow rate of our coolant is 52,000 kilograms per hour. And now we see the fraction of raw material to the complete increase, the amount of coolant. That is now the maximum amount of coolant is supplied, and as much as possible. And so it's been supplied, and the control valve is open for 100%. The cooling agent consumption is maximum. Here is 100, about 50,000 kilograms per hour, because all shadow valves and manual valves fully open. And the share of distillation is about 25%, but our goal is condense the product as much as possible, and we have to increase the difference between the raw material and temperature and the coolant temperature even more. And we have now changed the amount of coolant but we can still influence the amount of raw material. Is not a control valve. There isn't a control valve here. You can see it. Only manual valves. So we understand that cooling medium is maximum. Heating medium is not maximum, but there isn't control valves and shutter valves here. So we should decrease the amount of heating medium. To do this, let's find raw material, feedstock, manual valves, and try to gradually close it. Let's close it to 5% to 95%. Yeah, it's enough. Yeah, that's enough. And you can see that the distillation ratio between to decrease little by little. That's great. And the flow rate of our heating medium and coolant is the same. And to make the distillation ratio near to 0, let's try to close our let's closing our raw material heat exchanger, heating medium, raw. Yeah, and you can see that in this mathematical balance of flow rate device, and yeah. Yeah, and we can stop our exercise at this step, because here it's very hard to have a 0, because even if we fully close our manual valve Z11, some gases can be in our heat exchanger in pipelines, and our quantity device will show this. Yeah, and we can understand that we have completed the technological. Yeah, here see that some liquid, some vapor phase still in the our pipes show quantity device show us this. Yeah, yeah, and let's try to fully stop and shut down our heat exchanger. And sure, one heat exchanger cannot cope all production, all heating or cooling. And we should install another heat exchanger as a plant, and some of the raw material will go into it. And we understand now. We understand how heat exchanging system working. So we should understand that heat exchanger is very expensive, and all facility on the raw refinery is very expensive, and we have to work with it very carefully, and we always start the device from the cooling circuit and turn it from the hot circuit. That is, the heat exchanger can work with one whole circuit without hot flow, but it's cannot work with only hot one, because this can melt heat exchanger and melt pipes. So if we start um, our heat exchanger from the hot, very hot medium, it will melt our facility, our heat exchanger. So now let's try to shut down our fully stopped our heat exchanger. We have already stopped the raw material in that. So let's continue. We have closed Z11 smoothly, and the next step is stop outlet of heat exchanger. And let me remind you that on the field workstation, we can, on the field, simply say, we can close only manual valves and monitor all parameters. But if we want to close devices and valves that can be open or close remotely, we have to use we should use distributed control system. So let's close the path for our coolant. First of all, close inlet of our coolant. Next is outlet of our coolant. And opening the drainage to drainage our pipes. Drainage of heating medium is the hills manual valves, and the fifth manual valves is a drainage. And flow rate device shows us that there is no flow rate in our heat exchanger system. Next, let's visit distributed control system room, and on the Turk 6 device and manual valves. fully close TV6 control valve. That is, we can say that we finished work with the heat exchanger. And let's see. There isn't any flow rate. All is done. But we should sure close our drainage valves. And now we can finish this. We can finish exploration of heat exchanger and correctly finish exercises and scenarios. It's very important in working in our software. So click finish, and we can save our exercise by saving it is as incomplete. And in this case, it will be saved in your statistic and as unfinished exercise, and you will have an opportunity to get back to this scenario and save it. If you save as completed, it will be reflected in your personal statistics, and it's very important in competitions. When you will take part in the competition, you always should save your exercise as incompleted if you want to pass your result. So let's finish as completed. And while our software is relaunching, let's some reactions like or heard, and I'm here to answer your question. If you have any question, don't hesitate to ask me. Okay. Next simulator is Reboiler. Let's open it in training mode as the third simulator, Reboiler, and technological process management. And as I said here, Reboiler usually used in rectification columns. So here, working stream is the bottom stream. Let's use CF mode and start our calculation. There isn't a column here because we are work only with the Reboiler, but you should understand that here is 50 or 60 meters column in the near in the simulator. And in the Reboiler, the column cube product is manufactured and has the same product, is heated up more, and it's returns there in heaters and column cube and support the temperature that is necessary for oil column to work well. The common product is heated by superheated gas and superheated boiler. And let's see cross section of our boiler. If in a heat exchanger only shell, it's like a heat shell, like a shell and tube heat exchanger, but sure, here you can see why it's very, very important support enough liquid filling of our boiler in in our boiler. Because here is liquid and liquid or medium, and it is heat or cools. Yeah, let's get back. And here, the liquid phase and gas phase, some liquid evaporates by heating, and is the outlet of our column. Yeah, here is superheated gas, and its heat our bottom product. And let me remind you that we have signalizing levels and alarm levels. If tooltip are written in yellow, there is alarm levels, and that is highlighted in red, and emergency signals that have already led to an accident. And let's look at why the reboiler has an alarm signal of the 30% and an emergency signals of 15%. And let me show you across. Yeah, I have showed you a cross section of our boiler, and the narrow part is a pipe section, and here is bottom heating and condensation section. Yeah, and it is very important to not leave hot circuit. In this case, the pipe space without cooling. Therefore, the degree of filling of heat exchanger is approximately 15% here. This is an emergency. That is, if the level falls below this space, the heat exchanger will overheat it and possibly break down. Accordingly, 15% is emergency level. And let's make a situation. For example, the Coleman cube started to cooling down, and accordingly, raw material must be fed to the Coleman cube. That is what we can do this. We can heat the gas at the outlet of our boiler, and accordingly, we need our temperature device to show the higher values. Of course, the exceeding the signal valves, and two device is a heated bottom. So these yellow pipes show us this stream to our common. And let's go to DCS control room, find here two device. And in normal conditions, here 200, the set point is 297 Celsius degree. But let's open its trend and try to set here 305 Celsius degree. Not sure this result. And we can see that device in automatic mode controls the heating medium, and now it's near to higher level, higher alarm value. And what happened else in the system? Due to the fact that temperature is rising, the level in the boiler should fall because we increased the temperature respectively. Due to evaporation, gas production should increase. For example, our Fear 2 device. Um, and the flow rate has increased significantly because a lot of gases were formed and now entering to the Coleman cube. Accordingly, the level should fall because more liquid has begun to pass into gas. But now the level of heat exchanger is our level device LZSD show us that the filling degree is 15%. Yeah, and I will repeat um, um, I will repeat some theory. Yeah, and about alarms, how you can use them. Open logs, operating action log, and here you can see that we have set it, we have adjusted use set point, and it is 305 Celsius degree on our main temperature device. Next, SUG trigger log. And here, no ACD actions, but if we try to do something abnormal, it will be reflected in our logs. Process parameter logs, here you can see all devices. It's what they measure, flow rate, temperature, level, quantity, or something else, current value, set point, lower log level, higher log level, and other parameters. And status of shadow valves and control valves. Here, normally in shadow in when we use shutdown, when we shut down our simulator, all valves should be opened. Ensure to fully clean our pipes, use drainage. It's very important in the shutdowning of our in shutdowning scenarios. Yeah, and if you have any question, visit our help center and explore theory here. Show photos not working here, and one of the main feature is um, is a virtual structure, but here there isn't virtual structure. So let's finish. There isn't any virtual structure in technological process management mode. So let's finish it as completed. Yeah, and now I will announce conditions of our competition. Competition starting immediately after this webinar. All details will be repeated in WhatsApp community. But now the competition scenarios that should be done in today or tomorrow in 24 hours. It is in a control testing mode, normal startup, and normal shutdown of our reboiler. The best way, what you can do now, it is open a churning mode, repeat buffer tank, reflux tank, heat exchanger, reboiler, especially. Try to done normal startup, normal shutdown a lot of times in training mode. If you have any question, direct them to our WhatsApp community. Me or my colleagues will help you. But train normal startup and normal shutdown. Normal startup, sure, harder than normal shutdown, because you should lead all production to normal conditions. Yeah, train. Don't open. On at this step, you don't need a mine treatment unit, potential separation unit, primary distillation unit. I hope we'll have one more and a lot of collaboration in the future. And sure, if you want, well, we will teach you and show you how to use a mine treatment unit between separation in another. But now, train in this for simulators. You can use normal startup and normal shutdown of Reboiler in a training mode as much as you want, but before a deadline, you should done a normal startup and normal shutdown of Reboiler in a control testing mode, and only your first done scenario will be it will be the final result. And do it finish it and finish it as fast as you can. And only your first result in a control testing mode during the competition period will be counted. Yeah, and in this 24-hour, you will repeat all scenarios. You will finish one time control testing in the control testing mode startup and shutdown of our reboiler. How to prove is your result in your statistic or not? Open your personal statistics here and find your results. In particular, today we have done a Reboiler normal startup in a test mode. I want to open it in a test mode, and it's not a Moscow time. It's United time. Begin time, duration, active, and or result. And if all is okay, that's okay. If you have done the results in correct mode, but you don't see this in your personal statistics, let us team know in a WhatsApp community or in support chat. Yeah, and if you finished your exercise as incompleted, you can back to them in this. If you have any problems with a personal computer, it's turn on or turn off. Try to find your exercise in autosave exercises. Yeah, and how to correctly share your results in our community. When you done a Reboiler normal startup, you choose startup, open it, and here there isn't any virtual instructor or help. You only started, done the steps, actions the step by step. After that, in the normal time of startup is about 20 minutes. The normal time for shutdowning is 5 minutes. So click after you finished startup or shutdown, you can save it as completed. And the better way is make screenshot of your screen, and here you can see your result, your relax, what is okay, what's not okay. Is the best way is always get here, and this version structure protocol you can find in training mode, and the virtual protocol between estimation of control in a control mode and in a training mode is the same. So yeah, make a screenshot or photo on your phone and send them with your email, with your login to our WhatsApp community. And yeah, is the best way because only if you let us know, if you publish your results in WhatsApp community, we will count your result. If you done all correctly, but we haven't find your result, we can't add you in a winners list. Yeah, and that's all. If you want, you can, after the competition, you can open the mine treatment unit, butane preparation unit, primary distillation unit, all theory already on our YouTube channel. Yeah, and if you have any question, let me know. Yeah. And now let's have a 45 minutes break, and we will continue with our business development manager from Nigeria, John, at 2 p.m. Indonesia time. See you, and prepare your question for our next part.